Another systems of linear equation example, the circuits example. This time we're asked to solve it using Cramer's rule. Again, we've got the same setup. I'm going to go ahead and switch over to our sheet. That essentially we have two currents, I1 and I2, measured in amps. We know they fit this system of equations. 10 times I1 plus 4 times I2 equals 6. 4 times I1 plus 12 times I2 equals 9. And we want to solve using Cramer's rule. So for Cramer's rule, we set it up similar to what we did with the matrix algebra setup. If you remember, we broke it down into A being the matrix of coefficients, 10, 4, 4, and 12, that they match up there, such that when we multiply it by our variable matrix, vector I, we get what's on the left-hand side, and then B marks the right-hand side. And so what Cramer's rule wasn't anything really super complicated, but basically what he realized was, well, if we do this, we can get to this same answer by, if we have these variables x1 and x2, we can figure out what x1 is by taking the determinant of this new matrix A and dividing it by the determinant of our coefficient matrix, and this new matrix for variable 2 divided by A, determinant A for that one. And remember, determinant of A, if this is A equals A, B, C, D, if we remember what that is, that's the A times D minus B times C. And what he used to get these special matrices is basically he just took the normal A, our coefficient matrix, and just replaces one of the columns with the values of B. So whichever variable we're trying to solve for, if it's the first, we're trying to solve for the first one, we replace the first column with matrix B. If it's the second one, we replace the second column with matrix B. And so let's see how that works out with our particular example. I'm going to zoom out so we can see everything. So if I'm doing that for this one, then A1 is going to equal, I take the first column and replace it with this. So it's going to have 6 and 9, but still 4 and 12 here. And then A2, it's going to keep the 10 and the 4 in the first column, but it's going to replace the second column with B. So I'll put my 6 and my 9 there. Alright. Then I've also got, I'm going to write it down here just because we're doing everything else, that A is still, I probably should have written it first, A is still 10 and 4 and 4 and 12. So I know to get these answers going forward, I'm going to have to get the determinant of each one of these. So let's go ahead and do that. The determinant of A1 then is 6 times 12 minus 4 times 9. So the determinant of A1 is 36. The determinant of A2 is 10 times 9 minus 6 times 4. So the determinant of A2 is 66. And the determinant of A we've solved before, but just to make sure we get it right again, it's 10 times 12 minus 4 times 4. So the determinant of A is 104. So what they say is that x1 and x2, so in this case, my values are I1 and I2, that I1 must be the determinant of A1 divided by the determinant of A. And so for that value, we get 36 over 104, which, if you've done all the parts of this, you remember again, 36 divided by 104 0.346 amps. And for I2, if we move up the page a little bit, I2, which is going to equal the determinant of A2 divided by the determinant of A, is going to equal 66 out of 104. 66 divided by 104 is 0.635 amps. And again, system of equations, you can always plug them back in. They should work in both parts. We've done this now 4 times. We're pretty confident in those answers. So the new thing there was using Cramer's rule.